I'm on a Mac right now, not a PC, but depending on whichever device you're using, there's different releases. You want to be using probably the most recent version, but Python 3 is what you're looking for. So if you wanted to download it to Windows, you'd click on this, and then you'd have all your versions for Windows. You'd probably download this stable release of Python 3.13. Since I'm on a Mac, it gives me this link here because it detects that I'm on a Mac. If you're using Linux, they actually have a version for Linux from 2 weeks ago. And any sort of documentation release schedules you can find here. So if you were to download it, if you're using a Mac Windows, you would have it download to your downloads folder. You'd upload it, install it. Um, if I download it through here, it's going to download to my folder. And then if you have a MacBook, you drag it to the applications folder, and then it will install. Now let me show you what it looks like in the IDE as well as the command. I'm trying to find it here on my computer. Here we go. So on my computer, I have this idle shell. So this is basically your Python's downloaded to your computer. Um, there are two ways in which you can access it. Well, actually three. The first way you can access it is through the idle shell, which is basically kind of your environment that allows for you to kind of manipulate, write programs, save them as programs.py files, etc. You can also use it for the command line as well. It's a little bit, I think in Windows computers, you might have to install Ubuntu onto your computer and do a couple of wonky things to make it work in the command line. Whereas with a MacBook, it kind of installs to your command line, and you just have to basically call Python off of your device, and then you can run commands as you would um, as you would in Collaborate. The difference is when you're running it on your native computer, you're going to be um, using your computer's processing power to run the code versus where on Collaborate, you're using some sort of cloud-based server through Google that's running the code. So if I wanted to just import math, just to import a package and then just have it print hello world, and then it prints hello world. I could have it calculate. So I could have it define a function, calculate radius. And then it just says, or not radius, sorry, circumference or area. Let's do area. It would just take turn r times math.py. See what it does. There you go. And now it returns me. So what it did was it took the area of 2 times 2, then it took pi from the package of pi and did 3.14589752, whatever. If we wanted to create a specific program here, I can run a new file, and what I can do, so in here, the idle shell is basically running it like a command line. If you want to make a program like you're doing in kind of Collaborate, you could just basically create a new program by going to new file, and then you can do whatever you want. So you can be like, okay, print hello world. We'll import math again. And then you can define a function of area again. And then you can run basically an input is the rate. What is the radius of your circle? Let me make sure you're seeing what I'm seeing. Oh, you're not. 1 second. Here we go. Now you can see what I'm doing. So I basically opened a new file in idle. So I went to file, new file, and then I basically imported package. I'm having it print hello world. I'm defining a function, having it ask what is the radius. And then you can say, okay, R is equal to input. And then you can have it run area of R. And then you can have it print the area of your circle is probably going to give me some sort of error, but whatever. So in order for you to run the function or the program, you have to save it as a file on your computer. So I'll save it as area test, maybe if it lets me type. Doesn't want me to type. It's giving me problems. It's because I got to stop sharing it 1 second. Okay. So let me share this again. So what happened was is that once I saved the file, I went to idle. Up along the top, you'll see idle, and then you'll have run module. You have to save the file on your native device as a Python program to do it. And then once I did that, see it's pulling from on my command line, it's running the program. It's pulling from the document file name area test.py. And then it says hello world. Now it's asking me what the radius is because that's what I asked it to do. So I'm going to say 4. I hit enter and then it fails because, oh, because I changed the program. Let me run it again. There we go. Let's see here. I know what's happening. I forgot the input is a string and I need to convert it to an integer. There we go. I guess it's not returning the function. Welcome to the world of debugging. And so this is what happens when I do things on the fly. So I have it running and it's supposed to call the area function and then it's supposed to spit out the area based on the return, but it's not doing that. So let's figure that out. There we go. So now it's working. So what is the radius for? And now it's printing out the result. The reason why it didn't print out the result before is because I was having it return, but it wasn't printing anything. So this is taking 4 times 4 times pi and giving you that answer. So if you're running things on your native device, so if we end up doing more complicated processes, know that you're going to be bound by the limits of your device. Now, everything we're doing is using very minimal computational power. So you can probably do everything that we've done so far on your native device if you haven't done so already. But the fact of the matter is that whether you're using a third-party ID like PyCharm or maybe VS Code or some other compiler, Mu, I know is another one that people use for Python, you're going to basically be running things similarly, where you're going to save files on your native device. You're going to pull them in through that third-party IDE system. And then you have to kind of make sure that you're organizing things properly because next week, maybe I think it's next week or the week after, we're going to start opening in files from different locations. And so in your environment, whether it's your Google Drive environment or on your native computer, you need to kind of know where those things are located because you're going to be calling it from that location. So if you, let's say you move something from your documents folder to your downloads folder or your downloads folder to your documents folder, it's not going to pull it in properly because your file source is going to be different. So you might have the right name of the file, but if it's in a different folder, you got to make sure it's in the right folder. So next week we'll be pulling in files and Collaborate from your own native drives files, and you'll need to make sure that those are labeled properly, so that way you can access them. So again, let me show you what I was doing here. Okay, so here's what your normal Python file, see how it's saved as area underscore test.py. In your computer, in your files, you're saving things as .ipnyb, which is actually known as a Jupyter notebook. So Jupyter Notebook is kind of a combined markdown file where you can run code and also have text separately from it. But traditionally, your Python files are going to be saved as .py. So if you have a Python file as a .py file, you can actually run that file in your native Python on your computer or on your IDE, your third-party IDE like Mu or PyCharm or something like that. So how many of you have... Okay, so one of the topics I wanted to address today that can kind of help aid with your code development is something called try except. So one of the important things is in the debugging process, throughout this process of making code, you've probably run into dozens of errors where like something you create a program and you're like, okay, it works, and then you type something in and then it just doesn't work anymore. And then you're like, oh, there's a key error, or this is not defined, or this isn't in the right format, and you have to kind of beat your head against the wall for like an hour trying to figure out what's wrong with it. Well, one of the ways to circumvent that while you're creating your program, or if you're having someone else execute your program, is to implement a try except command into your program or into your function or whatever thing you're trying to develop. And what it does is it basically allows for you to create a set of commands, almost kind of like a Boolean, right? So like in a Boolean situation, you have to kind of come up with all the iterations that might be possible. So if you're trying to find a number between like, I don't know, 1 and 10, you're like, okay, well, if it's less than 1, you have to say this. If it's greater than 10, you have to say this. If it's in between, then it does this. And if it's not, then, and if it's an integer, then it's not, or something like that. Or if it's a float, then you're like, well, okay, pick a number between 1 and 10. Okay, well, do you want a rational number? Do you want an integer? Do you want an irrational number? So I could pick pi. That's between 1 and 10, but that's not what you're looking for. So, one of the ways in which we have historically done it is with conditional statements. We say, okay, well, if else, elif, all this other stuff. But there are going to be times where you're dealing with a bunch of different variables. You have a function that is pulling in variables that may or may not be defined yet. And so what you can do is you can create a try except command that keeps your program from erroring out, basically. So one of the problems that happens is you'll have something and then the thing isn't satisfied, so there's nothing within the bounds of your conditional statement, and so the code just stops running and says error. What a try except does is it allows for the code to keep running instead of um, basically crapping out. So, sorry, I was like multitasking. So in this example, we've defined x equals 5. We have a try except here where it says try print x except if x doesn't exist, say x is not defined, and then it will keep going and we'll go to the next line. So if we have x defined, it's going to just print x, which is 5, and then it's going to print this 5 plus 5 statement, which we know 5 plus 5 is 10. If we didn't have this statement, okay, so let's block this out. It's just going to print 10. That's fine. But what if we just get rid of x? What if we just don't define it? Well, if we just run this, it's going to be fine, but what if we try to print x? Oh, well, let's try y instead because y we know isn't defined yet. We get an error because y is not defined. Okay. Well, if we put in this try except statement, we put y in instead. Remember before, we have no y defined. There is no y anywhere. The reason why x came up was because stored in our containers, x was already defined before, so it's still saying it's still 5. But we haven't defined y at all in this notebook, so there is no existence of it anywhere. So when we tried to print y before, without the try except, we got this name error, and it didn't print out the 5 plus 5 anymore. We lost out on the ability to do that mathematical calculation. But now with the try except function, what it's going to do is it's going to look and see if y exists. If y exists, then it will print y. If y doesn't exist, it's going to print out y is not defined, but instead of the code stopping and not doing anything, it will keep going. So we have no y defined. The try didn't happen. The exception happened. So it told us that, but instead of it stopping and giving us an error, it just kept going and it kept printing and doing all this other stuff. So it keeps on Keeps on keeping on. So that is the new little nugget that's beneficial, is putting in some sort of try except that allows for the code to keep running even when you throw a wrench at it. So here it was like, okay, well, like we want you to print Y. Y doesn't exist. So we're going to just keep on going. Now, if we didn't have all this stuff after here, like it wouldn't be useful. It wouldn't really matter because there's nothing else to go after it. But what you want to do is you want to put this in here if there's code coming later in the program that you want to keep running even if something is missing. So, um, so maybe we want to define a function. And then I'm sure this is going to give me an error anyway, but because it's missing the argument, yeah. I was trying to play around with it and see if I could get this to work without Y being defined, but so for your assignment this week, not the exercise that you're doing for the Python file thing, but for your assignment prompt this week, I'm going to have you build in a try except into one of your functions or your programs for this week. So um, that's one new thing that I want you to be working on as well. The other thing that I want you to be trying out is something called regular expressions. So, um, basically, regular expressions is a way where you can create pattern recognition, uh, kind of manually instead of having to use existing functions or programs or packages or things like that. So regular expressions are basically little shorthand nuggets where you can basically have uh, a search through a set of text or a document and identify a pattern that you wanted to pull out. So let's say, for instance, you're looking for phone numbers or addresses or some sort of like data point, whether it be an IP address or something like that, something that's going to have a definitive pattern, but isn't necessarily something that you can easily pull out from your um like just saying, okay, like I'm going to do some sort of conditional statement where if this string looks like this, like that doesn't really work very well. One better way to do it is to use something called regular expressions. So regular expressions is a package that you can pull in and import into Python through um, RE. So RE is the name of your regular expressions package. And there is a kind of an alphabet and a sequence of different things that you can code into it, which is probably easier through a list than through me typing them all in. So let me pull it up from the text. Yes, here we go. Define the Here we go. So this is coming from your textbook for the Automate the Boring Stuff. So we have two kind of books. This one is actually coming from Automate the Boring Stuff rather than Python for Everybody. But basically, you could write a regular expression to search for anything with the letter X in it or the letter Y in it or any sort of specific pattern. Like maybe if you're looking for the word like who, maybe you just like have a regular expression where it's searching for all of the instances where the three-letter sequence of WHO comes in. So you might be looking for who, but if you have a document asking about who and it happens to be the World Health Organization, you might get a bunch of who's from the abbreviation WHO. So you can actually use regular expressions to, instead of finding all instances of the letter sequence WHO, you can have it be lowercase WHO or capital or lowercase w and lowercase ho, as opposed to just anything with WHO where it might pull in World Health Organization, might be the word who, might be the band The Who, could be a bunch of different things. So some of the shorthand character classes that make it a little bit easier if you're looking for like a bundle of things are the following. So this slash lowercase d basically will be looking for anything with a 0 to 9 integer digit in it. So what that means is basically if you were looking to create a regular expression to find phone numbers from a sequence of text, you might want to basically say, okay, instead of finding if the first number is between 0 and 9, do this. If the second number is between 0 and 9, do this. If the next number is between 0 and 9, do this. Like you could create programs that would search through the text and compile through and through and through and through all the numbers in a phone number. And you know the sequence of 3 digits for area code, 3 digits for number, 4 digits for number. That's how it is in the United States. You could do it like that. But there is something that we talk about in kind of a computer science programming world called O notation. Have any of you ever heard of O notation before? Okay. So O notation is basically when you run a program, the sequence in which it runs through the code is to some sort of exponential power. So if you were to run a regular expression, your O notation is going to be O to the first power because it's only going to run through the code sequence and say, okay, does this code sequence match every little piece of this regular expression? If it does, in this sequence, then I'm going to pull it out and save it somewhere else and report it to you. If it doesn't, I'm going to ignore it and move on to the next thing. However, let's say you created some sort of like loop that was going through each number of the sequence to see if it was a number, and then it would save it. And then if it was a number, it would save it. And if it was a number, it would save it. That would be like O to the nth notation because it would go through every single sequence every single time to see if every single thing was a correct thing. And that's a lot more processing power and a lot more time. Does that make sense? So basically, the way you code something needs to be efficient, and regex or regular expression allows for you to find a way when you're looking through a text or you're looking through some sort of compilation of numbers, how to organize that information, because that's going to be something that you're going to be really working on probably on your second project, and also something that you might be working on in the real world, where you need to have a compilation of IP addresses or a compilation of phone numbers. You want to be able to pull out the phone number, put it into a document. Think about all those like random letters you get in the mail that or emails you get that have your name on it. What it's doing is it's pulling from a spreadsheet of names and it's pulling out one column and it's going to spit it into that email address or that email, that form letter. And it looks like it's directed to you. So it's a lot more impactful for something to say Dear Bob to Bob versus Dear Valued Customer. So these are the applications to this process. So these are the ones that you would probably work with the most. However, the nice thing about regular expressions is you can basically make any unique sequence that you want for it to look through. So if you do this slash lowercase d, it's going to look for any numbers 0 to 9. If you do slash capital D, it's going to look for anything that's not 0 to 9. So if it's looking for, so if you want anything that's not a number, you can do slash capital D. Slash lowercase w will search for any letter, any digit, or underscore. So basically, the W stands for word character. So it's saying, is it a letter, is it a number, or is it an underscore? Capital W is the opposite. So basically, think about like complements. So whatever is not that, that's the capital. Whatever it actually is lowercase. And then slash lowercase s is any space, tab, or new line character. So if you're jumping to a new line, that would be an S. If there's a space between things, that's an S. If there's a tab between things, that's an S. And then capital S is the opposite. So you can create a regular expression that has the so I don't know if you're familiar with your keyboard, but that forward slash, is that a backslash or I think it's a backslash. That slash is usually underneath your backspace or your delete button on your keyboard. And then if you look at this kind of text up here where it says 0, kind of line 1, line 2, that is is in the same button as your backslash, but with with the shift key. That is known as a pipe. And so basically your pipe can be representative of any sort of or. So you could write out a regular expression that's seeking a number and do the actual numbers you're looking for. So 0 or 1 with the pipe, or 2 with the pipe, or 3 with the pipe. So this backslash D is a shorthand that covers all of that. So instead of you having to write out this whole expression of anything from 0 to 9, you can just do this, and that will take out your requirement. So we can use this to basically create a compiler that finds phone numbers from a set of text. So if we import regular expressions, RE, we can do a compiler, which is going to be RE, again, calling this package .compile. And then basically what I'm doing is I want it to run through the following sequence. So we're naming this compiler phone num regex. So it's basically saying phone numbers through regular expressions. If we look at this, what this compiler is telling us is forward or backslash D, the first character that I'm looking for is between 0 and 9. The next one is saying I'm looking for a number that's between 0 and 9. The third character is I'm looking for a number that's between 0 and 9. So what is that going to be? That's probably going to be your area code for a phone number. Area codes in the United States don't have letters in them, don't have anything but numbers between 0 and 9. So chances are I'm going to pull in a number that is 3 digits. Then the next thing it's looking for is a dash. So you might want to play around with that, like, because sometimes people use dashes for their phone numbers. Sometimes people use dots to separate the numbers. So in this case, as long as the phone number is using dashes between them, some use parentheses, then the dash between the 3 and the 4 digits at the end. So you might have to manipulate this regular expression to fit all of those iterations, or depending upon what your document is using. If your document is just using dashes, then this is fine. If they're using dots, you might have to cater to that. If they're using parentheses, you might have to adjust for those parentheses. But for this regular expression, we have 3 digits, we have a dash, then we have 3 more digits, so 0 to 9, 0 to 9, 0 to 9, then another dash, then 0 to 9, 0 to 9, 0 to 9, 0 to 9. So our regular expression is 3 0 to 9 digits, a dash, 3 0 to 9 digits, a dash, and then 4 0 to 9 digits. And then you have your quotations around here because it's trying to pull in the characters in the string. So then our test here is we're going to call this compilation, and then we're going to do dot search. And so dot search is going to look for the first instance of this coming up. And so if we have a text here that says my number is 231-555-4242, it's not going to give us the my number is because that doesn't match up with the sequence we're looking for. We could write in a million things in here. We can say my address is 4050 Quarter Line Road, Muskegon, Michigan 49442 or whatever. My social security number is 987-654422. Okay. I can run all that through. What's interesting, right, is that the specific sequence we're looking for is 3 digits dash 3 digits dash 4. The social security number is 3 digits dash 2 digits dash 4. So we should expect that it's going to compile the phone number, but it shouldn't pull in the social security number because it's going to get to this part of the sequence where it's expecting another number, and instead it's going to get the dash. And so it won't read that one in. And then when you want it to print the results of the sequences that it pulled in from the regular expression, you can do this test.group, open parenthesis, close parenthesis, to get your results. So when we do that, it only prints out this phone number. So we could even change this to show you, okay, the phone number is different. It's still pulling in that phone number. We could take out this phone number, and it should not give us anything. See, there's nothing in the sequence anymore. So it's not going to give us anything because there's nothing to report. We put it back in there. Boom, there it is. So here's the regular. So that's kind of a little example of how regular expressions work. So what I'll do here in a second, because I don't think I made available this week's assignment, is I'll unlock the folder for this week's homework or assignment, whatever. That's going to include basically a try except and a regular expression within the prompt. Your regular expression doesn't have to be a phone number. If I'm not asking for one, just be mindful of the fact that it might be something different than a phone number, so you have to come up with a different sequence to achieve that. So maybe it's an IP address, maybe it's a social security number. Just make sure that you realize that the sequence that you're looking for is going to match up with the sequence that you're trying to pull. So that'll be up in just a couple of minutes. And then your exercise for this week is to, if you haven't already downloaded Python to your native computer, download that, make a .py file of including one function of some sort that works, upload that .py file in up to Blackboard, and then that's basically it. So